diving into what angle and segment bisectors are, we have to just talk about some formalities and geometry. One big thing is to understand the difference between being congruent versus being equal. And when you hear the word congruent, what do you think it means? Things are congruent. Get it? The same. Yeah, that's all that congruent means. They're exactly the same. Okay? So, the wording you have to be very careful of. Segments are congruent. So, things, actual objects, are congruent to each other. Okay? Their distances or lengths are equal. Okay? So what that means is there's certain symbols we use rather than writing out long sentences in geometry, like this segment is congruent to this segment. Rather than writing out sentences, we love to use symbols. Makes our lives easier. Okay? One symbol you're going to see is the congruent symbol. All it is an equal sign with a squiggle above it. That's the congruent symbol. When you're stating that two segments are congruent, please use that symbol. So, for example, here it's stating that segment AB is congruent to segment CD because there's a line above, there's a bar above. Same thing with lines. Okay, you say the lines are congruent. When you're talking about their distances, though, if they have the same distance, the same length, you have to say that those distances are equal. So, instead of, when you're talking about their distances, and you're using the equal sign, don't put a bar above. Okay? So, if you're stating segments, how I like to remember it, there's a bar above the letters, you have to put the squiggle above the equal sign. If you don't put a bar above the letters, then there's no squiggle above the equal sign. That's how I like to remember it. Just know the difference. I'm not super picky with it. It's just more when you read directions or later down the road you will have like sentences with info in it. Just know the difference. Okay? And know that the equal sign with the squiggle means congruent, which means they're exactly the same. Okay. Yes.
Okay, so that symbol is different than like the equal with two squiggles, which means about over.
Correct. Yep. Yes, this means approximately. That means congruent. Congruent. And this just means approximate. So they're different. This means they're exactly the same. This just means kind of the same. Close to being the same. So it means two different things. Good question. So the incorrect way of writing it would be to have no bars and use the congruent symbol, or have bars and use the equal symbol. Okay? Just a really picky thing about geometry. They're very specific with their symbols. Okay? Same thing with angles. The actual angles themselves, they're congruent, but their measurements are equal. Okay? So same kind of thing. When you write it, when you're stating that angles are congruent, you just name the angle, use the congruent symbol, name the angle. Whenever you put a little m in front of an angle, so how these have little m, that's a typo. Squiggle out that. There, that should be cool. Okay. Whenever you put a little m in front of an angle, it means measurement. So this is saying the measurement of angle ABC is equal to the measurement of DEF. So there should be no squiggle above that. There is just make note. Gotta change it on yours, maybe not. So the incorrect way would be to not have the m's and use the equal sign, or have the m's and use the congruent sign. It's just a picky thing. I'm not too picky about it. But just so you know what those symbols mean. The little m just means measure of. This means congruent. Okay. Questions over that? No. Now we can start. Segment bisector. When you hear the word bisect, what comes to your mind? Bicycle. Two. Because bi, like bicycle, wheels, bisect means. Okay, two. What else? You kind of do it. You're on the right track. You kind of do it in science class. Sounds like bisect. Dissect. When you dissect something, what are you doing?
You're cutting it.
Cutting it. Right? So, bisector, when I see the word bisect, I was telling you I'm cutting it into two pieces. Okay, and what's really important about a bisector, okay, it's any segment, line, or plane that intersects a segment at its midpoint. What does midpoint mean? The middle, directly in the middle. So we are cutting something directly in the middle. So if I take this pen, perfectly find the middle, cut it perfectly down the middle. What do I know about my two new pieces? They're equal. Okay? So essentially what a bisector is doing is taking a segment, cutting it directly in half, and you get two equal pieces. Okay? To show that pieces are equal, we take a look at this diagram. This line right here, AB, is a bisector of the segment PQ. It's hitting it at its midpoint right here. So then what do we know about these distances? What do we know about the distance of QF and the distance of PF? They're what? They're the same. Right? One really important thing to know in geometry to indicate that segments are the same, you're going to see this a ton, is we put little tick marks on the lines. So to indicate that those segments are the same, we just put a tick mark. If segments have the same number of tick marks, then they're the same. If they have a different number of tick marks, then they're different. Okay? So if we take a look at this first example, okay, it says in the diagram below, CD is bisecting. This is a really important word. AB. Meaning this line right here is cutting the segment AB in half. When I see that word bisecting, that's what it means. Cutting it right in half, going right down the middle. If AM equals 24 and BM equals 10x minus 6, find the value of x. Something that's really helpful in geometry, label your diagram. Especially if you're stuck on how to set up the problem. Label it. Okay? So I'm going to label AM with 24 here, segment AM. And I'm going to label BM with 10x minus 6. And we're going to do this a lot in geometry. We have to take a vocab word and use that to set up an equation to solve for x. Do this a ton. You're going to do a lot in this unit, you're going to do a lot in this unit. Okay, so we have to figure out, well, how can I set up an equation using the info they gave me? They gave me the fact that we have a bisector. Good. You're just going to set them equal to each other. Excellent. Because we just talked about when something bisects a segment, you're cutting that segment in half. So the two pieces are equal. They're the same. They're congruent. And if we know they're the same, all you have to do is just set them equal to each other. And then just solve the equation. So little helpful hint. Whenever you see bisecting in your directions, you're setting two things equal to each other every time. Okay? Because the two things are going to be equal. So when we solve this, what's our first step in solving? Plus? Good. Add 6 to both sides. We get 30. And then what's our next step? Divide by 10. Divide by 10. And when we do so, x ends up equaling what? 3. My directions just said find the value of x. Found my value of x. I am done. So whenever you see the word bisecting, bisects, bisector, you're taking the two things and setting them equal to each other. And solving. Questions over that? In example 2, in this diagram below, segment DB bisects segment AC. So this guy right here is cutting this segment in half. Knowing that, we know it's cutting it in half. What do we know about AB and CB? They're what? They're congruent. They're the same. I'm going to mark it with tick marks. I think that's helpful too. The last one already has the tick marks on there. We want to find the length of BC. What's a little bit different about these directions?
They're telling you to find the length of BC, not x.
Good. Last question it said find x. This time around they're asking us to find actual length, right? But what do you think we have to find anyways to be able to find that length? X. You have to find, even though it doesn't specifically state in the directions to find x, you have to find it anyways to find that length. So we have a bisector. What are we going to do with those two expressions. Set them equal. Okay? We know they're equal, so set them equal. So we're going to say 4x minus 5 equals 11x, or 11 plus 2x. Again, bisector, set them equal. Ever see that work? Every time. Okay? So then when we solve, what's our first step in solving? Okay. Good. Subtract 2x. Move that over to the other side. We get 2x minus 5 equals 11. Now we're back to our basic little equation, 2 steps. What's our next step? Solving this. French, what's our next step? We add 5. We get 16. We divide by 2 to get what? Okay. We're done. We found x, right? We found our answers. We found what they were asking for. No. What did it say to ask for again? BC. Well, what the heck can we do with this x to find BC? So I say Allie. Allie. Perfect. All you have to do is just say 8. Go to BC, the expression for BC, and plug it right in there for x. And then plug that into your calculator. Okay? So to get BC, I'm going to say BC equals 11 plus 2. What are we doing with the 2 and the x? What operation? Multiplying. So it's 2 times 8, because we're doing 2 times x. And then plug that in your calculator. What do we get when we do 11 plus 2 times 8? What is it? Done. There's our answer. That's what we want. So if we know BC is 27 without doing any work, what's the distance of AB? 27. They're the same. Okay. Being bisected. Cut in half. Questions over that. And whenever you see bisector, just set the 2 pieces equal to each other. Okay. Question. There's a special type of segment bisector we're going to talk about. Okay. And that special type of bisector is called a perpendicular bisector. Okay, so it's still cutting a segment in half. Okay, that is true. But one important thing to note, very important vocab word, is the vocab word perpendicular. And when lines are perpendicular, that means they intersect and they create right angles every single time. So what's special about a perpendicular bisector is that it cuts a line in half, but it's also creating right angles. Those two things are happening. Okay? Perpendicular lines aren't necessarily perpendicular bisectors. They both form right angles, but a bisector is also cutting a line in half. Regular old perpendicular lines are just creating right angles. Okay? So we look at this diagram. In this diagram to the right, MN and PQ are perpendicular. So where they intersect, they're creating right angles. So all 4 of these angles, this angle, this angle, this angle, that angle, all 4 of those angles are right angles. Okay? Every time lines are perpendicular. Again, we love to use symbols in geometry. We hate writing out sentences. So instead of having to write this statement every single time, MN and PQ are perpendicular, we're going to use a symbol. And the symbol for perpendicular is an upside down capital T. So whenever you see that upside down capital T, that's just stating that the lines are perpendicular. Okay? So for example, instead of writing out this whole big sentence right here, we can just do that. A lot less writing to me. So whenever you see that upside down T, that just means lines are perpendicular. Okay? Questions over that? Again, perpendicular lines form right angles. Okay? A perpendicular bisector forms right angles, but it's also cutting a line. Okay? So just be wary of the 2 differences. So in this example, it says in the diagram below, CD is a perpendicular bisector of AB. Okay. So, what two things do we know? Huh?
The equation's going to be equal to 90.
Well, you're 2 steps ahead of me. What do we know about this diagram? If we have a perpendicular bisector, what kind of angles are formed? Okay? What kind of angles? A little louder. Right angles. Right? We know all 4 of these angles. This angle, this angle, this angle, that angle. All 4 are right angles because it's perpendicular. Right? It's also a bisector. So, what do we know about the distance of BO and AO? They're the same. So I'm going to put tick marks on it. Cutting it in half, I know they're the same because it's bisecting. That's what I like to do. I like to figure out what I know based on my vocab word, mark my diagram. Okay. Now that we marked our diagram, we know what's going on in the picture. It's saying the measure of COB is equal to 8x plus 50. Kind of fill that in. 8x plus 50. Okay. It's saying AO is y minus 7. I'm going to fill that in. AO, right here, y minus 7. And then BO is 11. So my diagram, my info. Right. Doesn't matter, which one do we want to find first? Do we want to find x or do we want to find y? Doesn't matter. X, let's find x first. So Ross, you were hinting at this. To find x, because it's a little different, we were given an angle. We were told that this angle right here is 8x plus 50. But we just talked about because it's perpendicular, they're all right angles. Ross, what do we know about the measurement of all right angles? They're what? 90. So if we know this angle right here is 90, we also know it's 8x plus 50, how can we set up that problem to solve? Yeah, just take the expression, set it equal to what that angle measurement is, which is 90 degrees. We know that's a right angle. We know right angles are 90 degrees. Set it equal to 90. And then solve. When we solve, just move the 50 over. We get 40. Divide by 8. So x is equal to 5. And did it ask for a measurement or just ask for x?
This is find it.
Yep, we found it. What else do we need to find? Y. How are we going to, not y, we have to find y, but you are correct. We have to find y. How are we going to set this guy up to solve for y? Ella? Good. Yeah, we have a bisector. Set those guys equal to each other. Okay. And then solve. Easy one-stepper. Add 7 to the other side. Y equals 18. So sometimes there might be more than one thing going on. But just know, set the segments equal to each other. We know it's a perpendicular bisector, set the angle equal to 90. You can't say that a segment is equal to an angle. You're not allowed to do that. So some of you maybe thought, well, I'll just say 8x plus 50 equals 11. Can't do that. 11 is a segment, 8x plus 50 is an angle. Not allowed to do that. Questions over that? Okay. Real quick, these last 2 examples are pretty quick. Same thing. You can bisect a segment. You can also bisect an angle. Okay? And it's just a ray or a line that's cutting an angle in half, creating 2 congruent angles. So we take a look at this diagram. BD is an angle bisector. It's cutting that angle in half, which means this angle right here, ABD, is the same as that angle right there, DBC. Those angles are exactly the same. Okay? To show that angles are the same in geometry, we just put little arcs inside them. Same thing with kind of segments. If angles have the same amount of arcs, they're the same. If they have a different amount of arcs, then they're different. So the same concept still applies for angle bisectors. Okay? We take a look at this example. It's saying that AB is bisecting CAD. So AB is cutting this big angle in half. So what do we know about those two little angles? Agree? They're congruent. They're the same. So I'm going to put arcs there. And if they're the same, come on, somewhere here. Where are my cards? They're the same. Chris, what can we do to set up this problem? We know we have a bisector. Okay? This angle is bisecting this red is bisecting this big angle. We just said that's creating two congruent angles. So what can we do? How can we set up the equation to solve? Good. Add 4x plus 1 equals to 33. They're the same, so set them equal. And then you just solve it like a normal equation. Move the 1 over. Divide by 4. You get 8. And all it said was find x, so we're done. We don't have to plug it in. It didn't say to find a measure of an angle, so don't. We just want x. Questions over that one? One more. Time to practice. So again, in this figure, ray QT bisects angle RQS. Okay? So again, what do we know about these two little angles if there's a bisector? They're the same. I'm going to put arcs there to show they're the same. Okay? It says SQT. SQT. That angle right there is 6x plus 5. It's saying that TQR 7x minus 2. Find the measure of SQR. Again, it didn't specifically say, hey, find x. But we have to find it anyways. We got that number from. Where did Logan get from? Logan. How do we set this problem up to solve?
6x equals 5, 7x minus 2.
We got it. We have a bisector. We know they're the same. Set them equal and then solve. And you solve these equations 8 million times. I keep solving them. We do it a ton in geometry. Method to my madness. Just move the 6 over by subtracting. Do the opposite. To get x minus 7. Add 7 to both sides. X ends up equaling 12. Let me see. Yep, 12. I feel like I did something wrong. Yes. Ah! Not 7. I was going to say, that's not what we got earlier. I feel like I did something wrong. Wrote something down wrong. Is my math right? X minus 2. That's a plus 2, so we get 7. There we go. That's what I wanted. Okay. Are we done with this problem? No. What do we need to find? SQR. Alrighty. There's S. Wait a second. Wait a second. They didn't give me an equation for that. They only gave me equations for the two small ones. What do you mean?
Like you do the plug in x for each equation, then you just find the answers.
Yeah. Do we have to plug them in for both though? You can't, because we have to. No, why not? Yeah, they're the same. So what one's going to equal, the other one's also going to equal. So it doesn't matter. Pick one. Do we want to plug it into 6x plus 5 or 7x minus 2? 6x plus 5. So I'm going to take 7, plug it in for x here. So I'm going to do 6 times 7 plus 5. Plug that in your calculator. What do we get when we do 6 times 7 plus 5? 47. Okay. So this angle is 47 degrees, which means this guy also has to be what? 47. And then what can we do with 47? There you go. Just add them together, multiply by 2. Doesn't matter. Just double 47, and that will give you the measure of the whole thing, which is 94 degrees. Questions over any of that? Just know, see the word bisectors. That means to set things equal. What do we know if we see the word perpendicular bisector? What two things do we know? Good. All the angles are right angles, and then you're also going to what? What do you know about the segments? They're what? Two pieces are the same. So you're going to set things equal, and you might have to set an angle equal to 90, because all the angles are right angles.